Alright, we're wrapping up our pictorial diagrams on the electrical circuit, low voltage and high voltage. So what I want you to do is draw this template out, this pictorial of your L1 and L2, 120 volts in common, a transformer 120 on one side, 24 coming out here. You got L1 and L2 low voltage circuit. Wire up your thermostat, wire up your fan relay, your heat sequencer, and your contactor in low voltage. And then from there, wire up your condensing unit, high voltage. And if you feel so prepared, go ahead and do your heat strips and your indoor fan motor, low and high speeds. Go ahead and hit pause. Draw this out. I'd draw it out real good one time, and then I'd make copies of that and then get you some colored pencils or markers and practice drawing this out. If you can draw this out electrically, you can wire it up electrically. But go ahead and hit pause and draw that out. And if you've done that, let's see if you've gotten to, this point here. Where's the point that I wanted to pick up? Oh, right here. So this is your low voltage circuit, and your condensing fan motor is hooked up. Do you feel ready to wire up the rest of it? Let's go ahead and help you out there. And open this up in an edit mode. And select something that I can draw things out. So we need some high voltage to our fan, and we need it high voltage going into the relay. This is the point where high voltage goes in, terminal 1, and this is going to go back to, oops, don't want to see, gosh, that's terrible. This is going to be L1, so that's going to go all the way back to your power source at L1, and terminal 3 goes to your high-speed fan, and your low-speed fan does not go directly to 2, because remember, this stays energized. You're going to run 2 to your heat sequencer, and the power is going to stop right there until it's called for. When low heat is called for, this will allow power to pass through, and you can run that power to your low-speed fan. You're also going to want that to go back to L2. Remember, L1 to switch to load back to L2. So we're going to run these back to L2, or common. I'm going to make a little terminal post just to connect them, get time together. And there you go. Now you got L2. Let's go ahead and get our L1 wired up too. Grab onto the terminal block and run that L1 wire right over there. That's my little connection. L1 to switch to load back to L2. We also want some heat to come on when our fans kick on, so let's run some staged heat. First stage of heat, and we'll make this our second stage of heat. All that sequencer is going to do is, just like the word sequence, it's going to delay so that they don't both come on at the same time. It's going to stage it, so one will come on and then the other one will come on if it's necessary. So we've got our switch to load, but we need our load back to L2, so I'm going to go ahead and connect those. L2, remember my little terminal block there, and L2 there. Now everything is going back to L2. And we are set with that wiring. Go ahead and save that one, and we can look at it. So that's what we wired up. That is the low and the high circuit, 24 volts, and the 120, and actually your condensing unit's going to be probably a higher voltage, 220, but we won't worry about that right now. So if you understand this, you can wire up the system. And that leads us to ladder diagrams. Here's a ladder. Zoom into that ladder. And just like before, we've got L1 to switch, switch to load, load back to L2, but this is drawn out as a ladder. We still have the terminal blocks. Right there's terminal block 1, terminal block 2, so this is our 120. This is our common. This 120 is going to have a black wire. This common is going to have a white wire. In some ladder schematics, you will see before the switch a line drawn to a little heat coil that goes on the compressor, and then it ties in over here, because basically that's the one exception where you really don't need a switch. We want that compressor heater to come on as soon as it's plugged in, and that tiny little bit of heat is going to separate the refrigerant oil and the refrigerant, so the refrigerant will go away. Otherwise the refrigerant will settle and mix into the crankcase of the compressor, and we want a little bit of heat there to encourage the freon, the refrigerant, to migrate somewhere else, because the refrigerant always tends to migrate to the coldest spot. And we prefer to have the oil just as pure as it can be in your compressor to keep the life of the compressor at its best. They say the hardest time in the life of an outdoor condensing unit is the day you turn it on, because so many times that oil has not been allowed to separate from the refrigerant, and you turn it on, or the oil is just not even at the proper location, so just from moving it around, things like that. So they say hook it up, let it sit in place, and let that be energized for like 8 hours, probably 24 is the best, and then go ahead and kick it on. It doesn't happen though a lot. Here we got L1 to switch. The switch is open. Switch to load, and our load here looks like it's a fan relay. No, that's not a relay because we are in the high voltage circuit. So this is just the fan 1 and 2. And it's defaulting to 2, which is your low speed fan. Remember that fan relay that showed the 2? This is representing the fan relay, but it's representing the high voltage side. So you've got terminal 1 on your fan relay that we wired into. You have terminal 3 that wires straight to the high fan, high speed. You've got terminal 2 that wires straight to the low speed. Now this is probably, it's going to be the same motor, but it's got 2 different speeds, or 3, or 4, whatever it requires, but it'll have a different speed. So we're just wiring it up to low speed, terminal 2, but before terminal 2 makes it to the fan, because that's connected, we have to run it through a sequencer that's open, and this is not going to turn on the low fan unless it calls for heat. When it does call for heat, this switch will close, and then the low fan will be able to operate. Also on this ladder diagram we have M1 to M2, and this is the sequencer, and this here is our high stage heat. When it calls for the high stage heat, it's going to kick on, and here is our low stage heat. This will probably connect first, and then this one will connect next. This doesn't have to be a sequencer. It could be a solid state device, a little circuit board. Come on. This computer is running slow. very, very laggy. So we have L1 to the cooling contactor and terminal 1 for the condenser fan motor. And in here too you'd have a capacitor wired in, but it's not going to show all that. Here's your condenser fan motor, and that's going to leg 2, and we are breaking leg 2 through the contactor as well. You don't have to. It would turn on and off without doing that, but in this case it's a contactor with 2 legs that opens and closes. The compressor is shown there too. It's wired in parallel, and it goes back to that same leg and closes out. That completes the high voltage side. This represents our transformer, step-down transformer from 120 volts to 24, and our L1 to switch. And in this case, this whole dotted box here, this is the thermostat. See, the thermostat is just a complicated switch. This is set for either auto or on. When it's set for, here's your switch for auto or on. When it is set on auto, your fan relay will not engage unless it's called for and it's going to be connected to your cooling circuit for that high-speed fan. On auto, you don't need this to come on in high speed unless it's connected to the cooling circuit. On heat, it will bring that low speed fan on because that low speed is already wired in. To do that, it's going through your sequencer. So here's your heat. This little symbol means as the temperature rises, as the temperature drops, if it gets low enough, this little switch is going to make connection and it's going to kick on your heat. In cooling mode, as the temperature rises, it's going to meet a certain set point and it's going to cause the cooling to kick on. Yellow is cooling, white is heat, green is fan relay. And this is the low voltage circuit. And this is your switch, the thermostat. L1 to switch, switch to load, load back to L2. So now you've got the basics of a ladder diagram. Go ahead and try and draw out your ladder diagram. Draw this thing out, draw it from memory. And when you can draw this out from memory and your pictorial from your diagram from memory, and when you can draw out the refrigeration cycle from memory, you are well on your way to becoming an HVAC technician. And that concludes this session.